started this, this wasn't the best drawing. We're trying to draw an apple, because that's about how we left off with yesterday. That's a little better, okay? So if this is a depiction of the human heart, which I think we had asked yesterday when you're up at SDSU if you had the chance to possibly hold, maybe you just saw it, you didn't hold it, or look inside of it. Maybe you did, maybe you didn't. I can't really remember. But if we were to draw an accurate depiction of the chambers of this heart, how would we go about doing that? Because it's not like a window, okay, or even in this manner. It would not look like that. Why is that? And we did talk about that yesterday. So what are our chambers? Let's start with that. And where's the right ventricle? Okay. Well, if you have the right ventricle, chances are the left ventricle is over here, which it would be. So then, now that we got that established, okay. But now, what would be an accurate depiction? A nice 90-degree corner where they're all of equal size. Is that how we drew it yesterday? No, we didn't. What's a better way to do that? Was this straight down the center? Straight down the center? No, it was about like this. And then, I suppose you could say this is maybe more so about like this, okay? And it has to deal with the workload, okay? So when we're talking about workload, we're just talking about how far this blood has to be pumped, okay? So in this case, there's two circuits that we talked about. There's what and what. I don't know, maybe we're Googling it, I don't know. What is it? Okay. So with that, which one of these is the pulmonary, since you said that first? Okay. So what that means then, to be a little more accurate, it's on the back side and you really can't see that. Okay. And then the left ventricle, okay, is part of the systemic circuit. Because this is pulmonary, this is systemic, because a very large vessel that's coming up, and then I'll just put a dotted line to illustrate that it's on the back side. Okay. Does anyone know what this very large artery is called? It's not an artery. It's a what? Aorta. It is the aorta. Okay. So, and that's got specific ways to make reference to that too. Is since this is going up, this is the ascending aorta. Once you get to the top, this is the aortic arch. So no surprise, once you get to here, you're in the descending aorta. Then, what cavity is from here to your diaphragm? Because you have ribs named after them too. Okay, so this is the thoracic aorta until about, it's hard to visualize, but I'd say maybe we're just going to say right there, because the diaphragm is going to separate these two cavities, the thoracic on top and all your digestive organs, which is below your thoracic cavity. What do we refer to this part of your body? Starts with an A. Yeah, so this is the abdominal aorta down here. Then eventually what's going to happen is this is going to get down into the pelvis, and you're going to have one split off that way and one split off that way for the legs. Okay? This is the right iliac artery. This is the left iliac artery. Okay? But going back to this is probably a little too much here. Okay. I'm just waiting for the computer to warm up, and then we'll get back to it. Okay. So notice those blue structures. It's going away from the heart. Okay. So one of the things we talk about, if it's going away from the heart, is that an artery or a vein? Away from the heart. We hear vein, we hear artery. Okay, arteries go away from the heart, and with that, what is so tricky about this, and medical students probably make this mistake too. I mean, I wouldn't say it's not necessarily a mistake, but it's a learning experience, is what we said yesterday. When this blood is leaving the right ventricle, what structures are these on both sides of the heart? Take a deep breath. Yeah, those are your lungs, your right lung and your left lung. Okay? Now, when we talk about this, there's still other branches on this aorta where you have this, I believe it's the brachiocephalic trunk here, that then splits into an axillary artery to the arms, to the carotid artery up to the brain. This just has a left common carotid that goes up to the brain, and then that branches off to the left axillary artery. So this is sending blood all the way up to the brain, to the arms, down to the chest, and to the legs. So which one is pumping blood further? Which chamber then, according to this diagram? Yes, this is sending through the entire system. That's what we call the systemic circuit. Okay, so hopefully when we do that, we can somewhat illustrate why some chambers are larger than others. And even though this structure is blue, this is still an artery because it's going away. The reason that it's blue is because it doesn't have any oxygen in it. It's sending it to the lungs so it can exchange oxygen. Okay, so this is some of the content that we had talked about yesterday. Okay, so your 5, that's probably the beginning, okay? The 5 types of vessels, okay? Arteries are the largest, especially the aorta. Those branch off into arterioles. There's really no set definition that explains the difference between an artery and an arteriole. It's not like you say, okay, the aorta is an inch in diameter. When you get to an arteriole, that has to be 5/8 of an inch. There's really no clear-cut definition. They're just referred to as arterioles. Then linking arterioles to venules is these small structures called capillaries. And then from the venules to the veins that bring deoxygenated blood back to the heart. So this pulmonary circuit that we talked about is just sending blood that is oxygen depleted. There's very little oxygen in there. It's sending it to the lungs so gas exchange can take place. Okay? And this is probably something we're going to try to look at in the form of gross anatomy. Okay, because as you use a textbook, okay, that's just, if you want to call it regular anatomy. When you look at gross anatomy, that means you have a specimen, whether it's a mink, a cat, a pigeon, a lizard, any one of those, okay? Then that is gross anatomy. And then when we talk about finally the systemic circuit, that's where blood is branching off of everything from the aorta, going up to the brain, okay, and down to the legs. So, with that being said, who's got higher pressure, veins or arteries? Arteries, the pressure is much, much higher. Okay. On the show Sunday morning, I wouldn't picture everyone tuning into that at 8 a.m. on Sunday morning. That's when that show takes place. I can't remember if that was announced, but does anyone ever heard of the Foo Fighters? Yes? No? It's a musical band, okay? I believe this was down in maybe Rio de Janeiro. I think it was in South America. I'm not sure if it was in Brazil, but and I could be wrong with that, but I believe it was down in South America. It was a band member of the Foo Fighters who passed away suddenly and unexpectedly from probably some sort of heart failure. I don't know if it's a heart attack or if it might be something called a myocardial infarction. That's another maybe a fancy way of saying a heart attack. But this was certainly clear. His heart was led to believe 1.5 times larger than what you would picture as a normal person. Maybe 1.5 times is a little dramatic, but I believe it was stated that his heart was larger than the normal person. Okay? Not to be, I won't say biased, but critical of thinking about band members that perform, maybe after their performers, what may they do? I'm not saying that all of them do this. I'm not saying that maybe not even hardly any of them do this, but after a performance, what might some of them do? They might take illegal or illicit drugs, okay? And I'm not saying that's what happened here, but it is possible that when that happens, that's going to have a dramatic effect on that heart. And even if it has to work harder than the normal person, what could cause that? Well, if a person has lots of triglycerides and lots of cholesterol and lots of fat molecules rotating and circulating through their blood, those fat molecules can start to stick together, okay? And if that happens, it can start to narrow the pathway of blood flowing through arterioles and maybe even capillaries, and it's catastrophic if that happens inside coronary arteries. Where do you think maybe coronary arteries are located? Actually, in the heart itself, you have coronary arteries and coronary veins, because even though the heart is just known for circulating blood, it's still a muscle itself. It still has to be able to get the nutrients it needs. It still needs to receive the oxygen to keep pumping. It's when those arteries become constricted or maybe even totally closed off, they may have to go under a bypass surgery, okay? And what that does is it just clears a pathway for blood to bypass wherever that clot may have taken place or occurred. Okay, so in between the lungs, mediastinum or mediastinum, whichever way you want to look at that, it's possible to do CPR because underneath the heart, you have the vertebral column. On the top of the heart, you've got that, not all of the sternum, but a portion of it. So when you start to do those chest compressions on the sternum, it's still causing the heart to contract, not on its own, but you're pushing that with doing CPR. And then with the vertebral column underneath that supplies some resistance, provided you can't perform CPR on a bed or mattress. Does anyone think they might know why? Because as you're pressing down on an individual, if they're on a soft mattress, what's their body going to do you think? Yeah, there's no resistance there. Every time you press down, you're pushing the whole body down. Okay? So there might be some sort of, I don't want, if you want to call it a body board or something to that effect, that would be perhaps placed underneath them. And then when you start pressing down, okay, you have a better chance of providing resistance. Although, yeah, the whole mattress is still going to go down, but that board on there is going to provide that resistance so you can keep doing that CPR. Okay. So the heart sits inside of a fluid cavity, okay? You have an endocardium, an epicardium, as you can see here, and then finally the pericardium, okay? So when we talk about proximal ends of vessels, does that mean close to the heart or far away from the heart? There's proximal and there's distal. So if it's a proximal end of large vessels, is that close to the heart or farther away? Yeah, it's going to be closer. That's why it's called proximal instead of distal. That's right. Okay, where does that put us? Does everyone have this content that wants it? Okay, so what I'm thinking is that the chambers of the heart next, atria, okay, heart valves. Okay, I want to get through this slide and then we'll start talking about the valves tomorrow. I was thinking that I had purchased more than 2 of these, even though they're not very large, but you can get the idea. Okay. I guess maybe a little assembly here. So these are held together by magnets, so that will help. I suppose this is metal bar. fancy. Okay, if you're perhaps just tuning in, this is what we're talking about. I got a metal bar here. That. Well, that's threaded, that's why. I'll let you go ahead and finish that. So we got a left side for your group, and I'll quickly put this one together as well. So this is what we'll be referring to in the near future when we're looking at whether it's chambers or valves. That's what we'll be talking about tomorrow. Okay, so remember, you're always looking at a mirror image, okay, because when we're looking at this, this is also a mirror image. So this guy down here, it's a little easier for me, is this the left or the right ventricle on the bottom? This is the right ventricle, okay? And then as we open this side, and you can do that with your chambers, it just holds that by a magnet. Here we have the left ventricle, okay? So as you can see, anatomically speaking, which one appears to be larger, the right or the left ventricle? Certainly the left side, because what that does, if you tip this up, okay, what that does is way down in here at the top or the roof of that left ventricle, there's an aortic valve there. And this is your aorta right here, okay? So as that's coming up, this is your ascending aorta. This is the aortic arch, and then this is where the aorta starts to go down, or the descending aorta. Okay, and what we had tried to depict earlier, okay, what you see from, actually it's not so much that it's behind, but here you have coming out of the right ventricle, because it's sending blood away, because it's sending blood away to the lungs. You have the left lung on this side, then the right lung on this side, okay? It's blue, but it's still an artery. A couple reasons for that. One, it's going away from the heart, so that's always going to be an artery. But two, there's very little oxygen in there, so it has to go to the lungs for gas exchange. I see we're up to about 23 minutes, so we'll also continue with this tomorrow. So you should see a lot of these blood vessels on here as well. These are the coronary arteries and veins that we're talking about. And if they get plugged, anything beyond that, just like with a garden hose that's 30 feet, okay, if you have a kink there at foot 18, what happens after 18 feet and 2 inches? Is there any water there? No, you're shaking your head no, because there's a kink in there. Water can't get through there. Same thing happens to the heart. So that's why that's catastrophic if that happens. And it can be surgically fixed if you get to it in time. Okay, we'll catch up to you next time.